Greetings, Liceo! Welcome back to our YouTube channel. In this video, we will be discussing compound interest and its application in the real world. Hold up, before you watch this video, be sure to head on to our channel and watch our video on simple interest to know the basics of interest and have prior understanding of this lesson. The objectives for this lesson are to know the definition of compound interest amongst other terms, to know the different formulas related to compound interest, and to analyze and solve problems that include or require the solution for compound interest. Before we start the discussion, let us first define the necessary terms. Compound interest, in the simplest of terms, is the interest on a loan or deposit calculated based on both the principal amount and the accumulated interest from previous periods. Principal amount, the sum of money lent for a certain period of time at a particular rate of interest. Time, the duration for which the principal is lent, mostly calculated in years. Interest, the profit earned on lending a principal for a certain period of time. Interest rate, the percentage of interest earned lending a sum of money. Amount, the final amount of money left at the end, the sum of the original principal and the total compound interest earned.
With that said, let us look at the formulas related to compound interest. First, we have the maturity value formula. V equals P times quantity 1 plus R to the power of N, wherein V is the maturity value of the amount, P is the principal amount, R is the annual interest rate, and N is the compound intervals. For the formula used in finding compound interest, A is equal to P times quantity 1 plus R over N to the power of NT, wherein A is the future value of the amount, P is the principal amount, R is the annual interest rate, N is the compound intervals, and T is the time in years. We must always remember that the unit of our time should be in years. If the given isn't already in years, we have to convert it to be able to perform the solution properly.
Now, let us have a short test to be able to determine whether you understand the usage of the different formulas related to compound interest. Determine whether the following problems are looking for the compound interest or the maturity value. Number 1. An investment earns 3% compounded monthly. Find the value of an initial investment of $5,000 after 6 years. Number 2. Mr. A invested 100,000 pesos in bank fixed deposit at ABC Bank Limited. ABC Bank Limited pays 8.75% compounded annually. Calculate the maturity value that Mr. A will get provided he invests for 3 years. Number 3. Ariel takes a loan of $8,000 to buy a used truck at the rate of 9% simple interest. Calculate the annual interest to be paid for the loan amount. Time's up. Are you ready to find out the answer? Answers on the screen in 3, 2, 1. Did you get it all right? No? That's okay. We will now explain why the given problems are what they are. For number 1, the problem tells us to find the initial investment of the amount after 3 years, as well as how often the rate has been compounded. Therefore, we should use the second formula as it has all the values needed to satisfy this problem. For number 2, we have to look for the keywords. The problem's keywords are maturity value. It also includes the necessary variables to have the solution be satisfied.
for number 3. What? Why is this one neither? Oh, as you can see, the problem doesn't include the main keywords we are looking for, which are our compound intervals. It even states in the problem that it is simple interest. So, this one is automatically not solvable by the formulas in this lesson. If you got all that down, be sure to keep watching to learn more. If not, you may always repeat this video to your liking.
Now, let us have sample problems to apply our knowledge into real-world situations. Problem number 1. Ian would like to know the maturity rate if he were to deposit his 48,000 pesos savings into Banco Co. Incorporated. He finds out that the bank offers a 3% interest rate compounded quarterly for a year. Before we begin solving, we must first identify the values given. P. Our principal value would be 48,000 pesos, since that is the amount he wants to deposit. R. The rate would be 3% or 0.03 since he would pay 3% annual interest. N. The compound intervals would be 4 because the problem states that the amount is to be compounded quarterly, which is 4 times in a year. Let us now solve for the maturity value. Our formula is V equals P times quantity 1 plus R to the power of N. First, we substitute the values. It becomes V equals 48,000 times quantity 1 plus 0.03 to the power of 4. Next, we do the necessary operations inside the parentheses. It becomes V equals 48,000 times 1.03 to the power of 4. Then, we calculate for the value when raised to the exponent, which is 4. It becomes V equals 48,000 times 1.12550,881. And lastly, we perform the final operation, which is multiplication. Thus, V equals 54,024 pesos and 42 centavos. Therefore, the maturity rate for Ian's savings would be 54,024 pesos and 42 centavos if he were to choose Banco Co. Incorporated as his bank. Problem number 2. Jarek has 20,000 pesos in his savings account, paying 8% annual interest compounded monthly. At this rate, how much money will be in the account after 10 years? 25 years. Before we begin solving, we must first identify the values given. P. Our principal value will be 20,000 pesos, since that is the amount he already has in his account. R. The rate would be 8% or 0.08, since he pays 8% annual interest. N. The compound intervals will be 12, since it is stated that it is compounded monthly and there are 12 months in 1 year. T. The time in years for the first required would be 10 years, and the second would be 25. Let us start with the first requirement, which is the future value of the account in 10 years. Our formula would be A equals P times quantity 1 plus R over N to the power of NT. First, we substitute the values. It becomes A equals 20,000 times quantity 1 plus 0.08 over 12 to the power of 12 times 10. Next, we do the necessary operations inside the parentheses. It becomes A equals 20,000 times 1.0066667 to the power of 120. Then, we calculate for the value when raised to the exponent, which is 120. It becomes A equals 20,000 times 2.21964023454. And lastly, we perform the final operation, which is multiplication. Thus, A is equal to 44,392
pesos and 80 centavos. Therefore, Jeric will have 44,392 pesos and 80 centavos in his account after 10 years. Now, let us solve for the next requirement, which is the future value of his account after 25 years. We will use the same formula, steps, and values, except for time, which is now 25 years. A is equal to P times quantity 1 plus R over N to the power of NT. First, we substitute the values. It becomes A equals 20,000 times quantity 1 plus 0.08 over 12 to the power of 12 times 25. Next, we do the necessary operations inside the parentheses. It becomes A equals 20,000 times 1.0066667 to the power of 300. Then, we calculate for the value when raised to the exponent, which is 300. It becomes A equals 20,000 times 7.34024887,976. And lastly, we perform the final operation, which is multiplication. Thus, A equals 146,804 pesos and 98 centavos. Therefore, Jeric will have 146,804 pesos and 98 centavos in his account after 25 years. Let's have a recap. We have learned two formulas today that are related to compound interest, and they are the maturity value formula, V equals P times quantity 1 plus R to the power of N, and the basic compound interest formula, A equals P times 1 plus R over N to the power of NT. We use the maturity value formula in problems that require the variables related to the maturity value and the basic compound interest for the same requirements but including time. Always remember that our unit of time should always be in years. If the given isn't already in years, we have to convert it to be able to perform the solution properly. I guess that ends our lesson. That's all for today, folks. If you learned something from this video, be sure to like, comment, share this video, smash that subscribe button, and click on the bell notifications to stay updated with our uploads. Live Jesus in our hearts forever.